So welcome to the September weather briefing. I hope you all returned well from your summer holidays and are eager to work again. This weather briefing is intended to be a weather briefing shared by myself and Isolda. Unfortunately, I saw that Isolda dropped out just 1 minute ago, so I hope she will come back and hold her part. For the content of the weather briefing, sorry, this was the wrong page. For the content of the weather briefing, we wanted to have a look back on the summer in Lithuania. Isolda from the Lithuanian Weather Service should give a short presentation on that. Followed by my presentation, a review of the August 2013, focused on Austria. And I wanted to finish with the present weather situation. So, and since Isolda is not back, I will just start with my presentation, and Isolda will go on then a bit later. So let's focus on the last month, on August in Austria. It's a very interesting situation. It was an exceptional warm and sunny month. The image you can see here is the mean temperature. It's the, and what I have marked in color is the deviation of the temperature from the mean temperature over 30 years. And these 30 years are from 1981 to 2010. And you can see in the colors, it has been exceptionally warm for Carinth, this part here in Austria, southern part, for Styria, and for the Burgenland. The mean temperature for August was about 2 degrees warmer than usual, which is quite a lot. In the whole August 2013 was among the hottest 10 months since the recording in Austria started more than 200 years before. So the first recordings were from 1767. And until August 2013, there was a temperature record in Dellach im Drautal. This is somewhere here, position. It was 39.7 degrees Celsius on the 27th July in 1983, so exactly 30 years ago. And 30 years later, a new temperature record was measured at the same location in Dellach im Drautal with 0.2 degrees more, so we reached 39.9 degrees Celsius on 3rd of August. So I go to the next slide, and there you see a map from Google Earth. And I marked Dellach im Drautal. It's a small town in an east-oriented valley. It's the valley. The river Drau is flowing along. And one might be wondering why Dellach im Drautal is able to produce such high temperatures. Because it's in the middle of the mountains. Okay, it's in the bottom of the valley, but the sun insolation is a little bit hindered by mountains. So there are mainly two reasons. First reason is it's located in the southern part of Austria. So it's the possibility to get a bit warmer than the northern part of Austria. And then, and this is the most important reason, this is a valley with a limited air volume. And this air volume heats up rapidly. And here in the eastern part and in the western part of the valley, there is a sort of narrow point which hinders the exchange of air. So the conditions are very good for having high temperatures in summer when there's no current of the air, when the air stays in the same place. So by the way, on 3rd August I was also in Carinthia for holiday, and I was here on this place, so not so far away, but a little bit higher, so around 1000 meters, and on that day the temperatures did not increase more than 32 degrees, so it was quite nice on that day. But a few kilometers away from here you had 8 degrees more. 1 week later there was another heat wave in Austria, and temperatures this time broke the 40-degree mark for the first time since measurements began in Austria. And this time the heat wave hit the eastern part of Austria. 3 stations measured more than 40 degrees. These were Bad Deutsch-Altenburg, Neusiedl am See, and Güssing. Güssing just reaching the 40 degrees. And again, I have a map from Google Earth showing you the locations. So we are here outside of the mountains. We had an action of warm air from the south. Bad Deutsch-Altenburg near the frontier. I put a red mark. It's near the Danube. Then with the highest temperature, then we had Neusiedl am See. This is here near the lake, near the Neusiedler See. And Güssing is in the southern part of the Burgenland. It's located here. So we had a very strong warm advection from the south, and this led to the higher temperatures. So on the 8th August we were sitting in the office and betting which station will reach first the 40 degrees. And at the beginning, Wiener Neustadt was one of the favorite candidates because it reached 38 degrees quite early in the morning. But then a bit later it stopped with 39 degrees and did not move on. And the other stations then made the run. So much for the 8th August. Isolda is back now. I see her. Isolda, I will give you the microphone a bit later. I put my presentation a bit earlier because you were not here. And I know already that you will also come back to the 8th August, which was also a very hot day in Lithuania. So let's go to the precipitation. From the precipitation point of view, the situation was not so exceptional in August. We had quite normal precipitation rates. Though in some regions there was less than 50% of precipitation. So for example here in Vorarlberg we had -15 to -45% of the usual precipitation. Here in the eastern part of Carinthia, again, where it was already very hot, we had up to -50% of the usual precipitation. And here in the northern part also of Austria, and probably also in the Czech Republic, precipitation was not enough. It was only -25 to -40% of that what usually falls in August. So it was in some region very dry, but in the whole country it was quite normal. And there were some points here where we had a bit more than usual precipitation. Let's come back to temperature, but this time for the cold temperature, the coldest temperatures. The coldest temperature in August was reached at the Sonnenblick Observatory. It's very high in the mountains. It's at 3,109 meters altitude. You can see an image from the research station. Measurements at the summit of this mountain were taken since 1886, so very long ago. And the first station was this year. I tried to mark it. This little house with the tower on it. This was the first part, which has built 120 years or 130 years ago, and all the rest. This is part of the research station, and here people can live and stay the night. Has been built later. So minus 4 degrees for August is quite cold. On 21st August, as you can see here, below 1000 meters, the coldest temperature was 3.7 degrees on 30 August. And the coldest inhabited place was Obergurgel. It's nearly 2000 meters high, with a monthly mean temperature of only 11.1 degrees Celsius for August, so quite cold. And I have an image of Obergurgel so that you don't believe there are just 2 people living there. There are quite a lot of people living there. There are a lot of hotels. It's a famous ski resort in the winter. This photo taken in summer, and this people live from the winter tourism. And you see on this image the glaciers here on the mountain, and this is the next point I want to come to talk on. How did the glaciers behave this summer in Austria? You have to know that the annual mass balance of the glaciers is a very good climate indicator, and glaciers can only exist in regions where there's more snow accumulation in winter than can melt in summer for a longer time. Yes, so it has to be positive, otherwise glaciers will disappear. And this is the case since the 80s. At least in Austria, the glaciers lose more ice and snow than they get in the winter time. So glaciers are backtracking and reducing in volume. So it seems that the summer 2013 was a little bit different. The hot August days I just mentioned did not harm the glaciers as much as, for example, the hot summer in 2003. The reason was a long-lasting winter and a late snowfall in June. So we had a late snow cover with high albedo, and this protected the glacier ice over the summer months. I have here a comparison of 2 images. This is the Goldberg case. What you see here is the measurement platform from the Somblick Observatory I just showed before. And you have a view over the glacier, and you see the difference between 2012, where a lot of the ice and snow melted, and 2013, where the surface is quite larger. So I want you now to take your pointer and point on the ice of the glacier, not on the snow, but on the ice. Do you recognize it? Can you point on it, please? Yes, fine. Okay. The ice is very easy to recognize. It's the darker zone. Snow has a high albedo. Snow is here, and ice is dark. And at the beginning of the summer, the glacier is covered with snow, so it's completely white. And at the end of the summer, the glacier gets dark, gray, brown, depending on the dust which falls on the ice. So you see, in 2012, there is nearly no snow left, and all the ice of the glacier can be seen and is melting in the sun. So on a hot summer day, if the temperatures are very high, about 10 centimeters of the ice can melt. And for snow, it's even worse because it's not so compact. 30 centimeters of snow can melt. So for a very hot summer week, there are about 2 meters of snow which can melt. So this is quite a lot. I would like to show you a video now. It's a fast motion video from a special camera, which shows you how the snow is disappearing and the ice is appearing under the snow cover. So it's from the same point of view, and you see that the white surface of the snow disappear. I will start the movie again because this is melting. start the movie again. So you see how over the summer snow disappears, ice appears. And only when the snow disappears, the ice can melt. As long as the snow is on the glacier, the glacier ice is protected. Okay, so much from my look back on the August 2013. I would like now to hand over the microphone to Isolda before coming to the weather situation. Isolda, it's up to you.
Thank you, Andreas. And sorry for being late, but not everything depends on my wishes. So summer is over, and it is really a time to revise it. And I would like to talk about summer in Eastern Baltic shore. Before talking about this summary, I want to say a few words about myself. I am a chief weather forecaster and have been working since in this position since 2007. Severe weather cases, analysis, annual and monthly reports about it are the field of my interests at work. So let's start, and the main features I saw this summer: early start. Daily mean temperature reached 15 degrees very early this year, on 8th of May. It means that our summer started 1 month earlier than usually. Normal date is the first days of June. So we could mark that summer lasted even 4 months in Lithuania. And the mean monthly temperature in May had even 3.5 degrees positive anomaly, and similar positive temperature trend was on June, July and August. We had so warm and very wet summer, and also a few years before we had frequent tropical air flow, and the same was this summer. And I could see that just autumn started, and was sharp drop of temperature in the first days of September. Untypical and especially warm was June. You could see here 18 degrees, it usually is in July. And so just summer mean temperature had 1.8 degrees positive anomaly. And precipitation, in contrast, we had less this summer. It's unusual thing. And due to drier June and August. So let's continue, and we had tropical impact, as I mentioned already, and two features of weather it created: heat waves, as Andreas already talked about this, and severe weather events were due to this tropical air flow. Compared with the year 2012, we registered less severe weather events and very hot periods this year. And overall, we had 16 very dangerous weather phenomena in summer 2012 and only 7 events last summer. But we had 3 local dangerous hot periods this last summer. In 2013. So now more deep about hot periods. Every month had exceptional hot time. The end of May, June, July, and the first days of August also were very hot, and lucky we haven't reached 40 degrees, never reached in Lithuania. It was not observed this temperature, as Andreas told about Austria, but 35 degrees on the 8th of August was very hot, especially I should mention that it was high relative humidity there. So I will talk about more detail about this August period, warm, hot period. First to start from Europe, so you could see very well. I will want to yes, so you could see very hot flow from Mediterranean or from Northern Africa, let's say. So, and red warnings, so very hot, dangerous phenomena. Thank you very much for help. So, and really, when we looked at this meteor alarm, we were sure that this flow will reach Lithuania as well, and it happened. So from the hottest day situation, let's look at analysis. So convergence line in tropical air is very well seen, and if you look at 850 hectopascals, also very clear. You can see how it reached the Baltic region. So we were prepared for this. We issued warnings in time, and we calculated heat index. It was calculated, I show this only on 9th of, it was the last day of the hot period when temperature reached 30 degrees, but you can see that our forecast and fact was quite similar, except of maybe western and central part of Lithuania, but eastern part of Lithuania still remained in very hot air. And the period ended as usually it happens, with pouring rain, hail and squalls on 10th of August. And I hope you could see video. Our people, citizens, send us this video, and you could see about large hail close to Vilnius region, and you can see, I can see, but I don't know why you can't. So hot period finished, and now I will talk about severe weather time, and as we had free time period of hot weather, the same happened, was in connection with tropical air flow, also with severe weather. And I would like to talk more about the end of July, when we had sleepless night in the western part of Lithuania, and with really thunderstorms and pouring rain. And the next day in the afternoon, the system moved to the eastern part, and here, and then in the southern part of Lithuania we also had very heavy thunderstorms and rain. So first of all, a few words about seaboard in the western part, how it developed, this system developed. And you can see also tropical air. It was about 20 degrees and in the height of 850 hectopascals, and tropical flow here with where mesoconvective system developed close to our seaboard. So Tropopause was on 12 kilometers height, and meanwhile the height of cumulonimbus reached 16-17 kilometers. There were perfect conditions to develop overshooting tops with cold rings and warm tops of clouds. And if cloud temperature there is image, and you can see that even minus 70 degrees it reached, and as you remember, it was 30 degrees close to the Earth surface, so about 100 difference between Earth surface and cloud top. So was very good conditions to intensive convection to develop. And if we look at water vapor image and CAPE parameter, which was calculated by European Center, more than 2,500 joule per kilogram, and really very unstable column of atmosphere over Lithuania developed, and global instability index also was showed very high value. So it was close to the sea, as I already said, and rainfall rate in millimeters reached about 80 millimeters per hour, so very intensive rain. And it, during the night, in some places there were more than 100 millimeters measured. It means more than 1 month's amount normal precipitation. So let's go to the evening, and this system, as I told already, it moved to the east, and all precipitations were in the most intensive precipitation place were in southern place Lithuania, and you could see very well shoal water index less than 0, and temperature advection at 3 kilometers height, and cold air advection. That it means that from the Atlantic already cold air reached Lithuania, and also intrusion of stratospheric air also is clearly seen here. So big difference between tropical air which reached Lithuania and which was pushed by Atlantic air. So this only to confirm that ESTOFEX also predicted very well this region of instability, and the same CAPE parameter and temperature thickness ridge is very clear on this image. So before the event, and our people now have good equipment, mobiles and cameras, and they sent us perfect images, and you can see how it looks before this thunderstorm this convective system developed over Lithuania, and after this, the main thing, there were no squalls at all, but very, very heavy rain and big damage was done in our country, especially on the western part of Lithuania. And now to conclude, we should be prepared for tropical year in our region, in northern region. So we should follow the situation and the process, how it will develop in the southern part of Europe, and then how it will develop in our country. And usually extreme weather phenomena are local, and we should be prepared for this, and we need to be brave to make decision that very hazardous weather could appear in our country. We should discuss with colleagues and revise our archives, and the more knowledge and analyzed cases we have, the more experience forecast tends to be. And of course, additional satellite data with radar lighting should help better understand physical process and have better prediction and this phenomena and issue warnings in time. So many thanks to everybody, and thank you for your patience.
Thank you, Isolda. What a lovely summer you had, only 30 degrees.
Oh, I think 35 degrees was enough for us, really. We suffered so much.
Well, let's come back then to the present weather situation. I put the link to the video of the melting glacier in the text chat box. If you want to go there and watch it again, just copy this and paste this link. Let's go to the present weather situation. This is the Mass RGB image from last weekend. We still had a very summerly situation with a ridge here over Central Europe, giving us quite hot temperatures and nice summer weather. This is Saturday, but this should not last much longer, because here a cold front is arriving and pushing away the warm air from Central Europe with some moderate rain on Monday and Tuesday. It moved quite fast from west to east, and on Tuesday it already has been in the eastern part of Hungary and reaching Romania. And then we had a low pressure system coming from the north. Here it's over Denmark, coming to the south and bringing the autumn to us. So the weather situation is completely changed now. No more sunny summer days, but really autumn days. And this is the infrared image with the 500 hectopascal isobars from today, midnight. And you can see here the nice center of the low. Another one over the Atlantic in front of the Portuguese coast. Together with the surface pressure, you see that the surface pressure anomaly is not so expressed. That means that it's really an upper level low, and also here cold air drop over the Atlantic and over Central Europe, making the air to cool and bringing some rain showers. So really autumnal weather situation. Here I have the thermal front parameter joined to the satellite image. There are some nice cold fronts. Could you please mark some of them? I have also read that some of you were not able to use the pointer. I don't know if it's better now, but maybe you can point on some cold fronts here in the satellite image. Yes, why not? This is okay. A lot of experienced satellite synopticians. Very fine. Very nice. And you see that there are some secondary cold fronts here, or cold air developments. Even here there's some secondary cold front. Yes, fine. I erase now all the stars. Can you click now on the warm fronts? Maybe you can also detect some warm fronts. Yes, perfect. Okay, I could see 3 of them, and you 4. I haven't seen this here. Okay, this is also a warm front. Yes, fine. Yeah, that's very good analysis. Let's go to the next edge. Here you have the temperature advection, which is very helpful as numerical field for detecting warm fronts. And you say this is a cold front here, which was correct, and the warm front with the warm air advection. This is quite easy to detect when you have the strong cold air advection and the warm air advection opposed near each other. Much more difficult is the situation here, because this is an older system. It's an up-level low, as I told you, and then the temperature advection, which is here from 700 hectopascal, that means in the lower level, is not so clear and much harder to detect. But you were all correct, and this was a very nice analysis. So, I want to go on with the ESTOFEX. Isolda also liked ESTOFEX. She showed it in one of her images. This is the, it's written here, it's a forecast for today, 6 UTC, from yesterday, the 11th. And I think the situation is quite well reflected in this image. We have convection here in this cold front or warm front part, and we have a very strong convection in this at midnight here over Italy, which is well reflected also by the 2 ESO line, which means 50% of the thunderstorms are severe of the intensity. Yeah, and let's see what happens during the day. I'm going back on this image because I want to draw now your attention on a system which is on the image border, this here. Does anybody know what this here is? It's not so obvious, but maybe you have heard of it. Can you write it in the text chat box? Or does anyone, you can also take the microphone and say what you think. What is this here in the bottom left image? Cloud. Any idea? What can it be? And no idea. Okay, then I will give you the solution, but if you see the image, it's quite easy. So I go to the Atlantic ePort. Here it is. So it's very clear, this is a hurricane. Its name is Humberto. And this is the image from yesterday, 12 UTC. I wanted to show you the severe storm RGB because it shows very nicely the yellow color with the fine and small ice crystals, which indicates a severe updraft. So at the moment, the hurricane is moving northward. That means it's going in this direction to the north, and I'm curious where it will end. Maybe at 12 UTC we have another severe storm image, and we shall see if it's developing or decreasing when it comes into colder waters. Okay, so much for the present situation. I finally want to draw your attention on the next weather briefing, which will be held on 21st of October by Dunja. And Dunja is from the Croatian Met Service, and she's going to hold the next weather briefing. Thank you very much for listening and joining our weather briefing.